Hey there, space explorers! Welcome back to Time Pilgrimage, your guide to the universe's greatest mysteries. Today, we're diving deep into a cosmic clash of Titan's giant planets versus dwarf planets. Get ready to be amazed as we unravel the secrets of these celestial heavyweights. Did you know that Jupiter, the largest planet in our solar system, is so massive that you could fit over 1,300 Earths inside it? That's mind-boggling, right? Now compare that to Pluto, once considered our ninth planet and now classified as a dwarf planet. Pluto is so small that it could fit inside the United States. This incredible difference in size begs the question, what makes a planet a giant or a dwarf? What are the key characteristics that set these celestial bodies apart? Join us as we explore the fascinating world of planetary classification and uncover the secrets of these cosmic giants and their smaller counterparts. In the vast expanse of our solar system, planets are like cosmic siblings, each with its own unique story to tell. Among them, giant planets and dwarf planets stand out as fascinating examples of the diversity and wonder of our cosmic neighborhood. Giant planets like Jupiter, Saturn, Uranus, and Neptune are composed primarily of gases like hydrogen and helium. Dwarf planets like Pluto, Eris, Haumea, and Makemake are smaller and rockier, residing in the outer reaches of our solar system. Let's start with the giants, those colossal gas balls that dominate our solar system. They're massive, composed mostly of gas, and have incredibly strong gravity. Imagine a world so big that over 1,000 Earths could fit inside it. That's Jupiter, the king of the giant planets. But Jupiter isn't alone. It shares its giant status with Saturn, famous for its stunning rings, Uranus, the icy giant tilted on its side, and Neptune, known for its fierce winds. These planets are mostly made up of hydrogen and helium, the lightest elements in the universe. They don't have a solid surface like Earth. Instead, their atmospheres just get denser and denser the deeper you go. It's like diving into an ocean of gas. Now let's shift our gaze to the dwarf planets. These celestial bodies may be smaller, but they're just as fascinating. Unlike the giant planets, dwarf planets are rocky, much like Earth and Mars. Pluto, the most famous dwarf planet, surprised scientists with its diverse and complex surface features when NASA's New Horizons spacecraft flew by in 2015. Other dwarf planets like Eris, Haumea, and Makemake reside in the distant cold regions beyond Neptune, a region called the Kuiper Belt. So we have our contenders, the massive gaseous giant planets and the smaller rocky dwarf planets. It's like comparing a basketball to a marble. But size isn't everything in the cosmic arena, is it? Giant planets are enormous, with powerful gravitational pulls that influence everything around them. Dwarf planets, on the other hand, are defined by their smaller size and their location in the solar system. Understanding the differences and similarities between giant and dwarf planets is crucial to unraveling the mysteries of our solar system and beyond. Imagine trying to land a spaceship on Jupiter. Spoiler alert, you can't. That's because gas giants don't have a solid surface like Earth. Instead, they have incredibly thick atmospheres made mostly of hydrogen and helium. As you descend deeper into a gas giant, the atmosphere gets denser and denser, eventually becoming more like a liquid than a gas. Dwarf planets, on the other hand, are worlds of rock and ice. They have solid surfaces, much like Earth and Mars, which means you could, hypothetically, land a spacecraft on them, but don't expect a warm welcome. Dwarf planets like Pluto are incredibly cold and far from the sun, with surfaces covered in ice and frozen gases. This fundamental difference in composition and structure highlights the key distinction between giant planets and dwarf planets. The atmospheres of giant planets also contribute to their stunning appearance, like Jupiter's Great Red Spot and Saturn's rings. Let's talk about gravity, the force that shapes the cosmos. Giant planets, with their enormous mass, are the gravity kings of our solar system. They exert a powerful pull on everything around them, including their moons, nearby asteroids, and even the orbits of other planets. Jupiter, the largest planet in our solar system, boasts a gravitational pull so strong that it has captured dozens of moons. The gravitational influence of giant planets extends far beyond their immediate surroundings, guiding the paths of comets and asteroids and influencing the formation of planets in the early solar system. This immense gravitational force also affects the planets themselves, creating stunning atmospheric bands and storms. While they may not have the gravitational clout of their giant counterparts, dwarf planets are far from insignificant. Many dwarf planets reside in the Kuiper Belt, a region beyond Neptune that's home to countless icy bodies. These objects are like time capsules, preserving the remnants of the early solar system. By studying them, scientists can learn about the conditions that existed billions of years ago when our solar system was just beginning to form. Pluto, for example, remains a fascinating world, with its complex surface features and its intriguing moons, offering valuable insights into the outer reaches of our solar system. The discovery of new dwarf planets like Eris, Haumea, and Makemake continues to challenge our understanding of the solar system. Despite their obvious differences, giant planets and dwarf planets share some surprising similarities. They both orbit the sun, they both have rounded shapes due to their own gravity, and they both play a role in the grand cosmic ballet that is our solar system. Giant planets are like the lead dancers, their movements commanding attention and influencing everything around them. Dwarf planets, on the other hand, are like the supporting cast, adding depth and complexity to the performance. Let's start with the big guy, the reigning champion of planets, Jupiter. This gas giant is a true behemoth, with a mass greater than all the other planets in our solar system combined. Jupiter is like the older sibling who gets all the attention. It's the largest planet, the most massive planet, and it even has the most moons. One of Jupiter's most striking features is its Great Red Spot, a giant storm that's been raging for over 400 years. This storm is so massive that you could fit 3 Earths inside it. It's like a hurricane on steroids. Jupiter is also a true fashion icon, sporting a stunning array of colorful bands and swirls in its atmosphere. Next up, we have Saturn, the ringed wonder of our solar system. Saturn is most famous for its stunning rings, which are made up of countless icy particles ranging in size from tiny grains to giant boulders. These rings are so vast and bright that you can see them even with a small telescope. But there's more to Saturn than just its rings. It's also a gas giant like Jupiter, composed mostly of hydrogen and helium. Saturn also has a fascinating collection of moons, including Titan, the only moon in our solar system known to have a dense atmosphere. Titan's atmosphere is so thick that it creates its own weather patterns, with methane rain, rivers, and lakes. Now let's venture out to the colder, darker regions of our solar system to meet Uranus and Neptune, the icy outcasts. Uranus is the ultimate rebel of the solar system. While all the other planets rotate on their axes with a slight tilt, Uranus is tilted on its side. This unusual tilt gives Uranus some very extreme seasons. Neptune, the farthest planet from the Sun, is known for its fierce winds, which can reach speeds of over 1,000 miles per hour. Neptune also has a deep blue color which comes from the methane in its atmosphere. Methane absorbs red light, giving Neptune its distinctive hue. It's like looking at a giant blue marble hanging in the blackness of space. Now let's shift our focus from the gas giants to the dwarf planets, those smaller, rockier worlds that reside in the outer reaches of our solar system. Pluto may be small, but it's got a lot of personality. It's a world of ice and rock, with a surprisingly diverse and complex surface. When NASA's New Horizons spacecraft flew by Pluto in 2015, it revealed a world that was far more interesting than anyone had imagined. Pluto is also a member of a binary system, meaning it shares its orbit with its largest moon, Charon. But Pluto isn't alone in the Dwarf Planet Club. There's Eris, discovered in 2005, which is even more massive than Pluto. Haumea, shaped like a giant rugby ball, spins incredibly fast, and Makemake, named after a Rapa Nui deity, is another distant resident of our solar system. Giant planets aren't just big and gassy, they're like the cosmic guardians of our solar system. Their massive gravity acts as a shield, deflecting comets and asteroids that could pose a threat to Earth and the inner planets. Imagine a cosmic game of billiards with Jupiter acting as the bumper, sending those icy interlopers scattering in different directions. Without these gas giants playing cosmic defense, Earth would be a much more dangerous place, bombarded by asteroids and comets much more frequently. Think of it this way, Jupiter takes one for the team, absorbing impacts and keeping the inner solar system relatively safe. But their influence goes beyond just protection. Giant planets have played a crucial role in shaping the very architecture of our solar system. Their gravitational pull helped to herd and organize smaller objects like asteroids and comets into belts and clouds, sculpting the solar system into the structure we see today. It's like they were the cosmic landscapers, moving mountains of rock and ice to create a habitable zone for planets like Earth. And their influence continues to this day. The gravitational dance between Jupiter and Saturn, for example, is thought to be responsible for the long-term stability of the asteroid belt, preventing a catastrophic cascade of collisions that could send asteroids hurtling towards the inner solar system. While giant planets shaped the solar system, dwarf planets preserved its birth memories. These icy bodies beyond Neptune are cosmic time capsules, holding clues to the early solar system. Dwarf planets are like the ingredient list of our solar system. Made of primordial materials, they reveal our cosmic origins. Their pristine condition makes them ideal for studying the building blocks of planets. Their orbits in the Kuiper belt reveal the early solar system's gravitational interactions. The search for life beyond Earth is one of the most profound quests in science. Our own solar system holds intriguing possibilities for harboring life, and not just on Mars. Giant planets might not be suitable for life, but their moons are a different story. Jupiter's moon Europa has a vast ocean beneath its icy surface, potentially containing more water than all Earth's oceans. And where there's water, there could be life. Saturn's moon Enceladus has geysers of water vapor, hinting at a subsurface ocean teeming with microbial life. These icy moons offer a glimpse into the possibility of life in alien environments. Could dwarf planets also harbor life? Some scientists believe that dwarf planets like Pluto with their subsurface oceans could surprise us. Life is tenacious and adaptable, thriving in the most unexpected places. Discovering even simple life beyond Earth would be a paradigm shift in our understanding of the cosmos. So, who wins the cosmic showdown between giant planets and dwarf planets? The truth is, there are no winners or losers in the grand tapestry of our solar system. It's like comparing a symphony orchestra to a solo violinist. Both are magnificent in their own right, contributing unique sounds and textures to the overall harmony. Giant planets, with their immense size and gravitational pull, are the architects of our solar system, shaping its structure and influencing the orbits of countless smaller objects. They are the guardians, shielding us from cosmic threats and shaping the very environment that allowed life to flourish on Earth. Dwarf planets, on the other hand, are the keepers of our cosmic history, preserving the pristine conditions of the early solar system and offering clues to its formation and evolution. They are the underdogs, proving that size isn't everything, and that even the smallest celestial bodies can hold profound secrets. Together, giant planets and dwarf planets paint a picture of a solar system that is both awe-inspiring in its scale and intricately interconnected. Each planet, moon, asteroid, and comet plays a role in this cosmic dance, contributing to the delicate balance that allows our solar system to exist as we know it. As we continue to explore our solar system and beyond, we are constantly making new discoveries that challenge our understanding of the cosmos and inspire us to ask even bigger questions. The study of giant planets and dwarf planets is far from over. It's a journey of ongoing discovery, full of surprises and wonder. What new secrets will we uncover about the atmospheres of gas giants? What lies beneath the icy surfaces of dwarf planets? Could there be life lurking in the hidden oceans of these distant worlds? These are just a few of the questions that drive our insatiable curiosity and push the boundaries of human knowledge. So what do you think about these celestial heavyweights and their smaller counterparts? Share your thoughts in the comments below and let's keep the conversation going. Don't forget to like this video and subscribe to Time Pilgrimage for more explorations of the universe's greatest mysteries. Thank you for watching, and remember, the cosmos is calling and we must go.